All right. My name is Jacob Sherman. Today is September 11th, 2009, and I'm here on the campus of Oklahoma State University interviewing Dr. Robert Westerman. This interview is part of the O State Stories Project. This project is being conducted by the Oklahoma Oral History Research Program. Today, we're discussing the Magruder Research Plots and Dr. Westerman's career. Thank you for being here, Dr. Westerman.
Thank you. Thank you.
Okay, first off, can you describe for me a little bit about your family background, where you grew up, and
Right. I am a native of the state of Oklahoma. I grew up in southwest Oklahoma on a cotton wheat farm,
Mhm.
and I graduated from Snyder High School in Cowell County, and then went to Cameron University for a couple of years, and then came up here to Oklahoma State and received a BS and MS degree. I have a BS degree in agricultural education and an MS degree in agronomy soils.
Mm-hmm.
And then at that particular point in time, I went into the military as an officer after having gone through ROTC here, and served most of my career, 3 years in the military as a platoon leader of a helicopter unit. After being discharged from the Army, I entered the University of Illinois and studied soil fertility, soil chemistry. Received my PhD degree in 1969. Went to the University of Arizona as an assistant professor, assistant professor of soil fertility, soil chemistry, and after 7 years at the university, I was fortunate enough to be able to return here to Oklahoma State University, and I've been employed here at Oklahoma State University since 1976. I came here as an associate professor, advanced professor, regents professor, department head, assistant director of the Agricultural Experiment Station, interim associate director of the Agricultural Experiment Station, and now currently serve as the assistant vice president for agriculture programs for the Division of Agricultural Sciences and Natural Resources.
Mm-hmm. That's quite a career. All right, when did you attend undergraduate? When did you attend school here as an undergraduate?
As an undergraduate, I came here. I transferred from Cameron. As an undergraduate, I was here from 1958 and followed 1958, and received my BS degree in January of 1961, and immediately entered into graduate college and received my master's degree then in 1963.
Okay. Can we discuss possibly your undergraduate experience too?
Sure.
Since this is a part of the O State Stories.
Sure.
All right. First off, where did you stay on campus? Where did you live? And
I originally was living with some friends in a campus apartment, which is still here, by the way, about the corner of Knob Block and I forgot the name of the street, but it's across the street from Chris's Sports store now, off of Knob Block there.
so like on Third there.
Yes,
Yes.
it is Third, isn't it?
Yeah.
Right?
And what was that living situation like?
It was good. There were four of us as roommates, and it was close to campus, and we had a lady that owned that particular complex was also served meals, and then we fixed a few meals ourselves, but we got by for a while.
And did you live there all 4 years or?
No, I married my wife,
Mm-hmm.
Sharon, who happens to be from Southwest Oklahoma also. And then after we married, we moved to a little small duplex on Husband Street,
Mm-hmm.
and then eventually moved into college housing in some of the apartments here on campus.
Now, so how did you meet your wife? Did you meet her on campus, or was she on?
No, we were raised almost together, about 3 miles apart,
Oh wow!
down in rural Oklahoma, Southwest Oklahoma. So we had known each other practically all of our lives.
Oh nice. And did she follow you up to school here, or was that?
Yes.
Oh. So what was her major?
Well, she just had an interest in general education. She was not able to finish her degree, but anyway, she was very supportive in helping me get through the program.
Okay. Now, what was your first impressions of Oklahoma State University?
Well, actually, I thought it was a very large school,
Mm-hmm.
much larger than I'd ever been accustomed to, because I came out of a little small rural school. So it was quite an experience to be among about 10,000 students at the time. As a matter of fact, when we were here, the student population increased to 10,000, and also the population in Stillwater increased to 10,000.
Oh, wow.
So at that particular time.
Mm-hmm. Now, was that kind of scary situation, or?
Oh, not particularly scary, I guess. It was just something that certainly we were not accustomed to.
Were you involved with any campus activities?
Yes, I was involved in a lot of clubs, undergraduate student clubs, such as the agronomy club, the ROTC, I can't remember, it's Scalbert. I can't remember the name of the club now, but and maybe one or two other organizations, Alpha Zeta for one, Block and Bridle.
Mm-hmm.
So some student organizations.
Now, did you have like any favorite spots on campus, or?
Well, in what regard, I guess?
Now, did you like have any favorite hangouts, or do you have any favorite memories of any locations on campus?
Really, the agronomy department per se, there were a group of us, I guess, that were there. There were students that worked together with other professors on projects, and that was a good time.
Mm-hmm.
A good learning experience for us, and really probably helped map the career that I chose.
Mm-hmm. Now, do you have like any campus memories that you're particularly fond of, or any traditions that you can recall?
We had the organizations, I guess, particularly the agronomy club, was a good leadership experience, and I enjoyed that very much.
Okay. Now, what was the transition like from being an undergraduate to graduate school? Was there a transition, or did you find?
Yes, there was quite a transition. One of the things that really became apparent very quickly was that the courses at the graduate level were moving at a much faster pace.
Mm-hmm.
Than what they had at the undergraduate level. I had been accustomed to taking 18 hours of coursework, that sort of thing, and with a graduate research assistantship, we were taking 10 hours, and you kind of have the false assumption that 10 hours is not very much academic load, but pretty quickly, due to the speed and intensity of the courses, you realize that there's a lot of material coming at you pretty fast.
Now, did you enjoy this coursework, or did you?
Yes, I did. As a matter of fact, I really enjoyed it. And I enjoyed the research that went along with it as far as the thesis was concerned. And so it was a good experience.
So what sparked your interest in agronomy?
Well, first of all, as I mentioned before, I came from a farm. And then the first job that I had on campus was sweeping the music building.
Okay.
And then I took a course here in the agronomy department, and I was fortunate to have made hundreds on all the exams and all the way through the course. So I didn't miss a single point on the course, and the individual that was teaching that course actually asked me to come to work for him as an undergraduate student, and then eventually I got my master. He was my major advisor for my master's degree in soils.
What was his name?
His name was Dr. Billy Tucker.
Okay. And he must have been, he must have been young at that time.
Well, he was probably about, I'm going to say that he's 8 to 10 years older than I was. So he had gotten here and just been here a short period of time.
Now, why was he such a big influence on you?
Well, first of all, he taught me a lot of things in regard to just basic soil science and agronomy, and he was also a very good influence on us in terms of leadership and how to work along with people and get things done.
Now, do you remember any other professors that had influences on you?
Here, Dr. Lester Reed was the professor of soil chemistry, and certainly I enjoyed his courses, and also enjoyed the opportunity to be able to visit with him as a student, which he did rather freely, and we had a lot of out-of-the-class discussions on a lot of different things, and I thought that was a valuable experience.
Now, what type of learner are you? Are you a book learner, or are you more hands-on?
Well, I think I'm probably more of a hands-on type learner, and that has helped a lot, I think. And where it has been beneficial, I think, while I could master things from the book learning, etc., the hands-on thing seemed to, of course, you seem to remember those experiences more than just, quote, reading a chapter in a book.
Now, what was your master's thesis? What area did you focus on?
It was primarily in soil fertility and soil chemistry, and it had to do with the adsorption of phosphorus in soils, and looking primarily at the effect of phosphorus fertilization on wheat yield, and also the resultant effect on water-soluble phosphorus in what we call a soil solution, and that's the liquid portion of that bathes the plant roots for nutrition.
Okay. Now, where did you conduct your research then for that?
My research was conducted on our agronomy farm at Perkins,
Mm-hmm.
which is about 10 miles south of here.
Now, is that still around or?
Yes, it is. It's on Highway 177, south of town, about 10 miles.
Mm-hmm. Now, did you have a car at that time,
Well,
or how did you get out there?
To answer your question, yes, we did have a car, but most of this work was Dr. Tucker, for example. We had a pickup in his project,
Mm-hmm.
and that was what we used to go back and forth to do experiments. But we had experiments all over the state of Oklahoma,
Mm-hmm.
and so we would travel and do the necessary things to establish those and harvest them,
Mm-hmm.
maintain them.
Now, were they called research stations at that time?
Well, we had a number of research stations, that's correct, but we also did a lot of work on farmer cooperative fields,
Mm-hmm.
where we get permission from a farmer to do. If we identified a particular nutrient deficiency for a crop, then we would do an experiment on that particular farm, and most often a lot of the times those would be on farmer fields.
Mm-hmm. Now, did you like doing those?
Yes, very much so.
Why is that?
Well, it's an opportunity to get acquainted with rural people, and they're the nicest people in the world to work with, and it also was gratifying, I guess, to be able to determine what some effects were that could benefit that particular grower or producer to help him increase his yield and profitability.
Now, do you remember like what kind of experiments that you helped with these farmers, or like
Yes.
for like a layman, what would you help them do?
What we would do in many cases would be to evaluate different sources of fertilizer materials,
Mm-hmm.
some of which were different sources of nitrogen, different sources of phosphorus, and then we did a lot of work with micronutrients out in the very western tier part of the state.
Mm-hmm. Now, is it can you explain like some of the differences of the soil types between like the western part of the state and say the central part of the state, where like we're at here in Stillwater?
Right. You know, Oklahoma is a very diversified state. Rainfall in the eastern part and the southeastern part of the state could be 55 inches of rainfall. In the panhandle out at Goodwill or Cimarron County could be 12 to 14 inches. And the elevation ranges from, say, like 550 feet in the southeast to over 4,000 feet in the northwest corner of the state. So as a consequence, you have a wide variety of outcrops of soils and geologic formations in which they form from. So there are 10 universal orders of soils that we order those soils into across the country, and 9 of those orders are present in Oklahoma. So we had the opportunity to work in a lot of different soils, a lot of different environments, and Oklahoma just is a wonderful environment to work in soil science because you got so many different soils to work with and different problems.
Now at that time in western Oklahoma, did you see some of the results of the soil conservation programs?
Yes.
And can you describe what those results were or what they were doing at that time?
Well, one of the things that we were doing at that particular time, we had a program where we were trying to promote what we call stubble mulching. Stubble mulching is a management practice where you leave a large amount of residue on top of the soils to prevent wind and water erosion, which is a major problem in western Oklahoma particularly. And so we had a number of educational programs and experiences trying to show farmers the benefits of stubble mulching, and also determining if there were different fertilizer requirements for this management system compared to the conventional clean till system.
Now, what would the stubble mulch consist of? Would it be straw being laid down?
Primarily, when we harvest the grain for wheat, for example, the tillage that would be used would be an implement that would have big wide sweeps that moved depth of about 4 inches under the soil, and rather than turning that residue under, it would simply cut it off, lift it up, and come back down on top of the soil. And so you had a lot of residue there to protect the soil from wind erosion and water erosion.
So basically, like the stalk of the plant.
Yes, it would be from the crown of the plant. As you know, wheat has multiple tillers on it, and so the combine, you might leave as much as 8 to 10 inches of straw on it, and that would be the residue that we're talking about that's on top of the soil surface.
Now, you came along in early '60s there, and was the results seen then? Was it working at that time?
Yes, it was.
Sorry.
It was working at that particular time. One of the problems that we encountered is that it was more difficult in this management system to control some undesirable weeds. We didn't have the chemical arsenal then that we have now, and so that made it a little bit difficult to promote that practice. But we did have a large number of people that adopted that practice.
Now, what kind of weeds were the problem? Were they like invasive species, or?
There could have been a variety of weeds. There could have been some bromus species, which are commonly referred to as cheat grass.
Okay.
We had some mustards out of the mustard family that are broadleafs. So there were a host of different weed pests, I guess, that sometimes were difficult to control.
And this was pre-pesticide era?
Yeah, it was prior to many of the chemicals that we had. They were just, at that particular time, they were just beginning to develop agricultural chemicals for weed control.
Now, did you guys do any experimentation on the pesticides, or?
Well, our particular area and expertise was in the area of evaluating plant food nutrients and sources of plant food nutrients. And we had other scientists in the department at that time that were working to evaluate chemicals for weed control.
Okay.
So what we would do is try to use the best chemical that had been shown to be effective from their research.
Now, did you work with chemical nutrients as well, or?
Yes, anhydrous ammonia, for example, ammonium nitrate, mono calcium phosphate, potassium chloride, diammonium phosphate.
Mm-hmm.
So most of our work were with what we call chemical fertilizers.
Okay. How did you apply those chemical fertilizers?
In varying ways. Some of them could have been broadcast on top, disc in. Some of them were placed in the row by the seed. We had some that were foliar applied.
Mm-hmm.
So we were looking at all of the methods of application, as well as sources of material.
Now, where would these sources come from?
Well, at one time in Oklahoma, we had approximately, I believe, 7 different anhydrous ammonia plants that were where anhydrous ammonia was being made. And anhydrous ammonia needs a hydrogen donor to make it, and so the hydrogen donor here in Oklahoma, of course, is natural gas, and we have a large amount of natural gas. And so from that process, they would also make, after anhydrous ammonia, they would make another product called urea, or they could make a product called ammonium nitrate. And so we did have a fairly large industry in the state for production of nitrogen fertilizers. The phosphorus is a mine product. It came from deposits in Florida. There's a little bit in northern part of the United States, but most of it was from the Florida deposits. Potassium, again, is a mine product, and we had some potassium mines in different areas of the state, not in the state, but in New Mexico and other areas of the United States where that was a valuable source.
Now, you transitioned, you did your PhD at the University of Illinois. Now, what did you continue your focus that you started here at Oklahoma State? Or did you work on something different or similar? Or?
Well, it was a different focus and probably a much more basic and detailed approach to try and help understand nutrient availability to plants. And in my research at the University of Illinois, I used stable isotopes, N15 particularly, to tag nitrogen fertilizer materials. And then I monitored the transformation of that material in soils, uptake in the plant, where it got concentrated in the plant, and then the total amount of the fertilizer applied that actually got into the plant. And so it was a detailed study, I guess. It involved a good bit of chemistry, particularly in analyses of the isotopes.
Mm-hmm. Did you work in the lab, or did you work on?
It was a combination thing. I put the experiments out in the field, but once we got the material harvested, the soil samples taken, whatever, that became a number of analytical procedures to isolate the varying compounds that we were looking at. And then finally, utilizing mass spectrometer to analyze the N15 content of the particular isolate that we were looking at.
Now, now was this field like on the South Farms, or?
It was on the South Farm, as a matter of fact, at the University of Illinois.
Mm-hmm. Now, did you work with the Magruder Plots at all, or no?
I did not have the privilege of working on the Magruder Plots. Of course, the Moore Plots was located very close to the library, as you know, and so I certainly was aware of what was going on, the purpose of the Moore Plots and that sort of thing, but I did not physically work on the Moore Plots.
Now, were you there when the undergraduate library was being built?
Yes.
Now, can you share some of that, your experiences with that?
Well, the Moore Plots, first of all, for those people that don't know, are the oldest continuous corn experiments in the world. And it so happened they're on the main part of the campus of the University of Illinois, and they wanted to expand the library. And of course, the growth of plants is affected by shade, and so basically it caused them in their library expansion to put the expansion of the library underground, so it did not affect the Moore Plots.
So how long were you at the University of Illinois?
3 years.
3 years. And did you work on, what kind of plants did you work on? Did you work on corn, or did you work on soybeans? Or
the particular plant that I worked on was a forage sorghum. It's a plant that produces a lot of biomass, and it's used primarily for feed for animals.
Beef feed?
Yes.
I think now after the coming out of the University of Illinois, you took a professorship at University of Arizona?
That is correct.
Okay. What was what did because Arizona is not known for its really agriculture because it's desert. So what kind of can you share your experiences about working at the University of Arizona and soil sciences?
Yeah, you are correct. There's only about 1 million acres of irrigated land in Arizona, but it's very intense agriculture. So we had some work there where irrigation was available. And then we also did some work with nitrogen transformations in soils on what we call the desert biome. And so we monitored a lot of the different nitrogen transformation in soils under semi-arid conditions. And then I did quite a lot of work in the laboratory where we did things under controlled conditions, and we're monitoring and determining nitrification rates and movement of nitrogen through soils in the transformation process.
Okay. And when did you come to Oklahoma State? When did you return to Oklahoma State?
I came here in 1976.
Okay. How did were you invited back, or how did you come to hear about this position?
Yes, as a matter of fact, I was invited back. There was a position that came open here at Oklahoma State that was to assume a leadership role for soil fertility, soil chemistry, which I was very much interested in. And so when I came here as associate professor, I assumed that leadership role and became the lead person in this group. And my appointment was primarily research, and I did teach graduate level courses.
Now, how did you become involved with the Magruder Plots?
When I came here as a lead person in soil fertility, I assumed the responsibility for managing those plots. My former advisor, Dr. Billy Tucker, was still here on the faculty at that particular time, and he had managed those plots a number of years prior to my coming.
Now we'll get into the questions pertaining to the Magruder research plots. Uh, First off, can you define agronomy for me or for the listeners?
Yes, agronomy is the study of plants and soils, basically, in very simple terms.
Mm-hmm. So is soil sciences, would it be similar to soil sciences, or is there a technical difference?
First, agronomy is crops and soils.
Mm-hmm.
You could specialize in one or the other, or sometimes a combination of both.
Mm-hmm.
So you can go, I guess, and get as detailed within each of those disciplines as you want to get,
Mm-hmm. Now, the Magruder Plots, they're part of the agricultural experiment stations, right?
That is correct.
And currently, how many agricultural experiment stations are there across the state?
We have 19 different locations today, and they're scattered all over the state, and they represent key soils in the state and selected environmental conditions for production.
Can you describe for me like the range? Like you talked about the experiment station out in the western part of the state. Do we have experiment stations in the southeastern part of the state, or?
Yes, we do. As a matter of fact, our furthest west experiment station is located in the Panhandle in Goodwill, Oklahoma.
Goodwill.
Our furthest southeastern station is located in Idabel.
Mm-hmm.
So we have a transit across the state from southeast to northwest. We have stations in the southwest, and we have a station in the northeast. So we cover pretty much the key soils in the state where ag production is important.
Now, like, is there a focus like in the southeast pertaining to cotton at all, or no?
Well, not today.
Not today.
Primarily in the southeast, it's forestry.
Okay.
We have recently acquired some land that was donated to us by Mr. McLinley. It's about 2,000 acres of land, and that consists of forage production. It has some timber on it, has some cons on it, and we're currently developing that, which will give us a little broader scope of research in the southeast than what we had before.
Mm-hmm. Now, was there cotton research?
At one time, cotton was grown predominantly across the state of Oklahoma, and it is, through time, I guess, and a lot of factors involved with that, cotton is not being produced in southeast Oklahoma these days.
Mm-hmm.
Our cotton production now is confined and concentrated mostly in the southwestern part of the state.
Mm-hmm. Now, the research stations also deal with like soybeans and alfalfa, correct?
Yes, we do. Right. We have basically all the major crops that are grown in the state of Oklahoma. There would be experiments at those experiment stations on those crops that are important to the farmers and ranchers in that area.
Mm-hmm. Now, how does the agricultural experiment stations work within the university structure?
Well, this is a good point. first of all, I'll start by saying that we have three agencies within the Division of Agricultural Sciences and Natural Resources. First, we have the College of Agricultural Sciences and Natural Resources, which is budgeted under the Oklahoma State University budget line.
Mm-hmm.
Then we have the Oklahoma Agricultural Experiment Station, which is a separate line item in our budget. And then we have the Oklahoma Cooperative Extension Service, which is a separate line item. So we have a line item in the higher education budget, just like Oklahoma State University does. What makes us different, and I think more powerful, is that we have about 58 to 60 FTEs in teaching in the College of Agriculture. When we add the Ag Experiment Station and the Cooperative Extension Service to that, we have a total of slightly more than 200. So we've increased our numbers by about 150. Now, our faculty, majority of them, have split appointments. So we might have a faculty member that has a 75% research appointment and 25% teaching appointments. So that means that he has all of this valuable experience that he's gained from research, and the students are getting firsthand information in his classes that he teaches.
Mm-hmm. Which is always a good thing. Now, can you explain about how the experiment station works within the extension services too?
The experiment station and the Cooperative Extension Service work hand in hand.
Mm-hmm. Experiment
station is the research arm of the Ag Division and the university. So we're in experiment station, we are discovering new knowledge, new practices, new technology. The extension service has a responsibility to disseminate that information to the producers, farmers and ranchers in a state. And so they would be taking the information that's developed on our experiment stations and conducting educational programs to help our farmers understand how best to implement some of these practices.
Mm-hmm. So basically, the experiment stations have two big outlets of dissemination. One being in the classroom and one being through the extension services.
Well, now the extension service is a separate entity, mm-hmm. but they take the information from the Ag Experiment Station. The classroom part, and you are correct, as long as you understand that Cooperative Extension Service is an independent line item in the budget, mm-hmm. and they have their own set of employees, and the Agricultural Experiment Station has its own set of employees, and the college has their set, mm-hmm. and then we have what we call a mixed set that can be appointments in extension and research, appointments in research and teaching, appointments in extension and teaching. So we have all combination and mixes of appointments.
Mm-hmm. Okay, thanks for the clarification. Now, how does the experiment station fulfill the university's land grant mission?
Well, first of all, if you go back and look at the history of the formation of the university here as a land grant university, mm-hmm. In 1862, the Morrill Act was passed that said that every state and or territory should have a land-grant university to allow anyone to go and get an education in agriculture and or in mechanical arts.
Mhm.
So that's a land-grant university, and that was initiated in 1862. Of course, at that particular time, Oklahoma was Indian territory. So, but we still had and fell under that act. Now, in about 18, I'm not sure what the date is now, but it's 1887, I believe, the Hatch Act was passed, and that provided funding for the agricultural experiment station. So and then it wasn't until about 2013 or so that the Smith-Lever Act was passed.
1913?
2000, excuse me, you are correct. I'm sorry, we're not there already.
Yeah, I know.
1913, that is correct. The Smith-Lever Act was passed,
Mhm.
and then that was a formation of the Extension Service.
Now, the first extension service was where? Was that Connecticut? Or was that the first experiment station?
The first experiment station was in Connecticut.
Wesleyan University?
Then that was, the Morrill Act, of course, set the stage for each university.
Mhm.
But every state has an experiment station.
Mhm. Now, what can you tell me particular about the history of the Magruder Plots? What's your knowledge of it? Can you give me a snapshot of the history of it for me?
Right. From the beginning,
Mm-hmm.
the Magruder Plots were established in about 1892 by Professor A.C. Magruder, who was the first professor of agriculture that was hired by Oklahoma A&M College at that time. He established the experiments as a very simple experiment that consisted of 2 plots, one being unmanured and one being manured,
Mm-hmm.
to determine the strength of the soil to provide nutrients for crop growth, primarily wheat. And these plots were located just near Murray Hall and Stout Hall. And as the campus began to expand in the 1940s, there was danger in losing the plots. These plots were further modified, I must say, by others to include different treatments of synthetic fertilizers, nitrogen, phosphorus, potassium, lime, as well as manure.
Mm-hmm.
And when it became apparent that the campus was going to destroy the plots with expansion, and there was quite a considerable amount of discussion and effort to keep them to preserve those plots. In about 1942, it became apparent that one of the dormitories was going to destroy the plots. So they made arrangements to move the plots. And so they took the topsoil out of each of those plots and kept it separate, the 0 to 6 inch depth. And then they did the same thing with the 6 to the 15 inch depth, because that is where the majority of the plant roots reside in crops. and they went to the present location, which was about a mile west and on our current agronomy farm, and excavated that area and placed that soil back in those varying plots. And in a very short time, they began to respond in a very similar fashion that they did in their former location. So those have been in place now since about 1942 out at the agronomy farm here. When I first came on board here in 1976, there had been discussion and eyes cast on the agronomy farm to establish a athletic facility. And so we became very nervous about that. Dr. Billy Tucker, myself, and another individual, Dr. Webb, worked very hard for about 3 years, and we were able to get the plots into the National Historic Register and to preserve those plots. And so that's where they reside now. And fortunately for us, the athletic facility renovation and stuff remained in its present location.
Now, can you how big are the plots? Like what are the dimensions, size?
The plots are about 100 feet in length, and there's 21 and a half feet wide.
Mm-hmm.
And the actual portion of that plot's about 17 feet, so that gives you a border in between of a few feet between the plots.
Mm-hmm.
And there are 6 plots. There's a check plot that has not received any fertilizer or nutrients of any sort for over ever since 1892. That's been in continuous wheat. So these plots have been grown in continuous wheat. There's a manured plot that gets animal manure. There's a plot that gets nitrogen fertilizer, a plot that gets nitrogen plus phosphorus, then nitrogen plus phosphorus plus potassium, then nitrogen plus phosphorus plus potassium plus lime. So those are the plots that are there.
How much acreage does it take up, the plots themselves?
Well, let's see. Plots, like I said, is 100 feet long, and we got 6 plots that are approximately 20 feet each, so that's 120. So that gives us approximately 100 and 120. We were probably thinking about a third of an acre, I think.
Doing some math.
Yeah. If you give me,
It's all right.
if you give me a minute, I'll tell you exactly.
I'm not a math major myself.
Well, it's about a third of an acre.
Okay.
There's 43,560 square feet in an acre, and but that's about what it is.
Now, do you think that the move affected the legitimacy of the experiment?
Well, we were very fortunate to have a scientist at that particular time that was managing the plots. He took deep soil cores out of each plot in several locations and analyzed the soils prior to moving them. And he determined that there wasn't any change. The treatment did not have any change below 15 inches, no matter what the treatment was here on campus.
Mm-hmm.
And so he went out to the present location at the agronomy farm and cored those same soils and determined that the subsoils below 15 inches were very similar.
Mhm.
So when he placed them back in on top of that same subsoil, then once the soil settled, they were back into the same form that they currently had. And I will say this, that the significance of the Magruder plots is that they are the oldest continuous wheat plots in the Great Plains and the second oldest in continuous wheat west of the Mississippi.
What's the Missouri's or?
The Sanborn plots in Missouri are about 4 years older than our plots are.
Now it's now what I keep always hear is that these plots are considered the second oldest research plot. Now, if Missouri's older, then why are we considered the second oldest research plot?
Well, the Sanborn plots in Missouri was established in about 1888.
Mm-hmm.
Magruder plots were established in 1892. So those guys are about 4 years older than we are.
Okay. Oh, I was just thinking in terms of relation with the Morrow plots.
Well, now the Morrow plots, remember, are corn.
Mm-hmm.
And they're the oldest corn plots in the world.
Oh, okay.
So we're talking about continuous wheat, where they've grown wheat on soils year after year after year.
Ah, okay. Now that makes sense. Comes to clear. Now now in terms of research plots, where do we rank as like being the oldest altogether? Do you have any idea?
We're probably about number 3.
Mm-hmm. Behind the
Morrow plots first, Salmon plots, and then the Magruder plots.
Okay. All right. I'm going to switch out that tape because it only lasts an hour. And then we're going to come back. I'd like to get into discussing how you guys became part of the National Historic Registry and the controversy dealing with the athletic field, proposed athletic fields.
Okay.
All right. So just give me a couple minutes here. Okay. I believe we're set here.
Okay.
We're back here with Dr. Robert Westerman. We're going to discuss the importance of being on the National Historic Registry and the controversy dealing with the terms of athletics wanting to take over the Morrow plots. So can you so set the stage for us? Like, what was the plan of the athletic department and what did they want to do? Or
what basically the plan, although it was never formally presented to us, we became aware of the interest of establishing a new athletic facility. And of course, if you're coming into Stillwater, Highway 51 and a large open research station to the left is an ideal location to establish a facility like that. And we did not want to lose the Magruder plots to a expansion of the athletic facility. And so we began to be proactive in our approach and work to get those plots listed in the National Registry of Historic Places in hopes that we could give them a permanent home.
now, describe that process for being listed as National Historic Registry.
Well, there is a particular set of forms and questions and that sort of thing that you have to document and submit, and then they have a group or a committee that rules, makes a judgment call as to whether this should be a historic location or not. And we were able to put the documentation together that was appropriate for them to grant permission to put it on the registry for the National Historic Places. We recently have an addition to that. One of the barns that we have out here on the agronomy farm, what we call Barn A, is that it represents the architectural structure and that sort of stuff of that period of time. And so we have that listed also.
Mm-hmm. Now, did you help certify that as a historic
Well,
place?
at that particular time I was in administration here. I knew it was going on, but there were other folks that were working to get that done.
Okay. Now, did you have to appear before a committee in person, or did you submit a paper? Or
this was primarily a submission of application forms with the documentation, and so we did not actually appear before a committee.
Mm-hmm. Okay. Let's see, what other questions were here? All right, who have been like some of the major researchers, professors working within the plots? Who have you worked with, basically? That's what I'm trying to ask.
Here?
Mm-hmm. On the plots themselves.
Of course, Dr. Billy Tucker, who I mentioned before. And then the current manager of the Magruder Plots is Dr. Bill Ron, who I served as major advisor for his master's degree here. So those two individuals primarily are the two major individuals that I've worked with on those plots.
So you're the link between the two?
I am, yes.
There we go. So it literally comes full circle, because
it does. I think that I managed those plots from 1977 to 1991.
And the current person took over in 91?
He took over in 92.
Okay.
To present time.
Mm-hmm. And Dr. Tucker was here?
Dr. Tucker was here, and he managed those plots as a major researcher from 1957 to 1976.
Oh, wow. So three people.
So the three of us have managed these plots for 43 and 9, 52 years.
Now does that continuation help preserve?
Yes, it does. As a matter of fact, some of the earlier folks that had responsibility for managing the plots may have only been there for 2 to 5 years.
Mm-hmm.
Dr. Ron and myself particularly was able to utilize a new statistical approach to analyze the data for over 100 years. And there's merit involved by having folks manage plots for continuously over a longer period of time.
And it also helps retain the institutional memory.
That is correct. That is correct.
Now, do students assist you out over there? Or?
Yes. As a matter of fact, students would be involved in planting and harvesting, taking soil samples, and any other measurements that we might take. So, and also involved in the analyses of those samples that are taken.
Graduate students or undergrads or
Both.
both?
Both. We would have folks. One of our natural entries into our graduate program is that we attract quality students at the undergraduate level. They work in our programs, and then if they're interested in pursuing advanced degrees, well, then we can move them into graduate level work, and they're familiar with a lot of the things that we do and how we do things.
So has there been a lot of thesis and dissertations come from them? Or?
Well, I personally was major advisor to over 55 students in my career here as a research scientist. I moved into administration in about 1991. That's when I gave up the leadership role for the Magruder Plots. Dr. Ron has probably served as major advisor of even more students than that. I don't know what his total number is, but it's significant.
Now, can you explain for us how the weeds are actually tested on and experimented on?
Over the years, wheat varieties have changed on the plots. Generally speaking, we keep varieties on the plots for a number of years so that we don't get into what we call nutrient variety interactions. So you have to have a consistent period of time to evaluate your nutrient treatments. Now, as a result of that, we're doing two things. We're taking probably the most popular and preferred wheat variety of the time when we change them. And then we establish it and we grow out the wheat for a number of years. And then after we get enough data to evaluate this process, then we'll change varieties. So we don't actually evaluate every wheat variety, but we do have a number of different wheat varieties that have been planted on the plots.
Now, you're trying to avoid like nutrient deficiencies by that, like the wheat plant trying to suck up.
First of all, there is a lot of genetic diversity in the plants, and as our plant breeders develop new varieties, they may have different nutrient requirements. And so, in order to gain the information that's necessary for the real mission of the plots, which is determining whether or not and how long these soils can sustain production, then we have to have some consistency in our varieties, or we won't know if it's a variety change or a change in the nutrient status.
Oh, yeah. Okay. Can you explain the differences in the wheat varieties? Are they just different seedlings, or can you?
They can be a number of different things. They have. Well, we started out, some of the first wheats that were grown are what we call turkey red, and those were wheats that were brought here by Mennonites, Kansas, and they migrated here to Oklahoma. And that was the first wheat we had. Very tall, small head, whatever. But through plant breeding, we've been able to increase the size and number of kernels in the head, increase yields, reduce the length of straw, and so it's generally an improvement. Also, the other thing is that through plant breeding, they've been able to incorporate valuable traits that might consist of disease resistance, green bug resistance, soil-borne disease resistance. And so you keep packaging these varieties with these different protection devices and you keep increasing yield. And so, but these protection devices may fail. In other words, they build up, organisms build up resistance to that, and then the wheat variety is not effective as it was, and so you have to come back with another generation. The strains change of the diseases.
Now, are any of the current wheat varieties genetically altered?
No, not on the Magruder plots. There's quite a controversy, I guess, on genetically altered plants, particularly wheat and those crops that are used for food cereal grains. And so we do not have a genetically altered wheat plant at this time. We had them research-wise, but not in production.
Okay. Because I'm aware of the controversy.
Right.
Now, what are the uses for these wheats that are grown on the Magruder plots? I mean,
those varieties represent wheats that would be used for milling and baking. Hard red winter wheat is the type that we have, and we grow in Oklahoma, majority of it. And it is the preferred wheat, I guess, for protein content and milling and baking quality.
Now, do you have corporations assist you with funding for this type of research, or?
Yes, we do. We're very fortunate in Oklahoma to have what we call a fertilizer checkoff program, whereby a certain fee per ton of fertilizer sold is devoted for soil fertility research. And that program, along with competitive grants that our scientists have been able to garner, supports the program. Supports the graduate student assistantships to get the work done and provides maintenance and operation monies. In about 1989, after a number of years of work, we were able to get a law passed in the state of Oklahoma that set up the fertilizer checkoff program for research in this area.
Now, is that program just for wheat, or is it for other?
No, it's for crops that are grown in the state of Oklahoma.
Okay.
So it could be any crop.
Now, what kind of knowledge has farmers gained from the research at Magruder Plots?
Well, the Magruder plots have been something like, to put it in perspective, I guess, is something like a barometer. First of all, if we have a favorable growing season, you might be able to produce 15 to 20 bushels of wheat, and they've never been fertilized. Under fertilization, that might be 45 to 50 bushels. And so what that has done and has been a very good teaching tool to our farmers and producers in the state. The other thing that is very important about that is that it is a measure of the decline of soil organic matter with continued tillage These soils were in grasses prior to the sod being broken out for cultivation, and they had an organic matter content of near 4%. And after 100 years of tillage, the organic matter content is 1% or less now. So there's a tremendous amount of nutrients that are stored in the organic matter. And it has now gotten to the point in the continuous wheat plot without any fertilization that it's depleted.
So can you take that organic matter and actually take it and look at like the history of the grasses here? Or is that even viable research to look at the content?
we can't really determine that. Those soils that the plots are in were all, quote, as uniform as they could be. They all had the same kind of grasses growing on top of them, so we can't make any differentiation. But what we can do is that we can look at the microbial populations in the soils. And there have been some studies that we have conducted on those plots to help us understand changes in populations of microorganisms that have different functions.
Okay, I was just curious about that. Now, what have you personally learned from the research done at being conducted at the Magruder Plots?
Yeah.
I knew I was going to slip one time here.
Yeah. Well, it's a kind of a continuing story, I guess. When the Magruder Plots were first established, the nitrogen in the soils that was continuous wheat depleted first. Then it was the phosphorus that depleted secondly. Then it was the potassium. I happened to be managing the plots when the first effects of a response to potassium fertilizer were detected. So that's a barometer of the reddish prairie soils. There's a Kirkland silt loam out here. But that's a barometer of the nutrient status of those plots. So it's been a continuing thing. One nutrient, one nutrient, one nutrient, one nutrient, and a line. So it depends on what period of time you're really managing those plots. I'm sure that, I know when Dr. Harper was managing the plots in, say, like 1942 or something, he began to see differences in phosphorus fertilization responses to that.
Now, over time, does the nutrient replenish itself or no?
Yes, you can, in the terms of phosphorus and potassium, you can add nutrients to put it into percent sufficiency levels that are adequate for plant growth, and you would not get a response. In the case of nitrogen, not necessarily so, because nitrogen happens to be a mobile nutrient in soil. That means it moves with soil water. And also it has many, many more transformations that nitrogen goes through and cycling in soil. Inorganic nitrogen can move into the organic fractions where they're not available for plants.
Now, over time, naturally, without you guys coming in and adding the nutrients, would that be replenished over time, or once it's done, it's done?
No, it would not. It would not replenish. First of all, there are thousands and thousands of acres in underdeveloped countries that are nutrient deficient, and it will be hundreds of years before adequate nutrients might be reestablished there. First of all, they have no place for nutrients to come from, as you know. They can't produce enough growth to mineralize nutrients from the organic matter that's produced. So
Now, can you over
over-fertilize?
Yeah, over fertilize. I was gonna say nutriize, but
Yes, and that's crop specific.
can you do it with wheat or?
In terms of nitrogen, yes. At times, if you, and it depends on the favorableness of the growing season. If you have adequate moisture and the variety of wheat that you have, you can get excessive growth, and during windstorms and whatever, and have a tendency to blow the crop over, or lodge as we call it. So that can be attributed to nitrogen fertilization, over nitrogen fertilization, but it also can be attributed to weak straw in the plant. So it's how you want to look at it. But in terms of phosphorus and potassium, probably not affect. I mean, you got to get it in that. You have to get in unreasonable rates before you'd ever see an effect.
Have you? Has there been a point where in the Magruder Plots that it's been over?
No.
You guys take steps to prevent that?
We have a constant rate of fertilizer for nitrogen, phosphorus, and potassium, lime, and manure that we apply annually. That rate doesn't change.
Now, what kind of manure?
Animal manure, cow manure.
Cow manure from OSU here, or?
Well, actually, in order to try to get consistency of it, we'll buy it from commercial source. And because we have to have a known nutrient content of the material we're applying. As you know, the animal manures can vary in nutrient content depending on how much straw is in them, how deep did you dig it out of the lot, a lot of other things.
Yes. Now originally was the manure analyzed, or was it just tossed on? I hate to use the word toss, but put on the plots.
Right. The manure has always been analyzed. And the manure rate is supplying about the same amount of nutrients, nitrogen particularly, that we have in our nitrogen plot.
All right. Now is there, when looking at wheat research, I know that University of Arkansas does wheat research. I know Minnesota has wheat research. Montana State, I believe, has some wheat research. Now, is there any differences within the wheat research, or how do you compare it to other institutions?
The differences are, number one, the kind of wheat that they're growing. They're used, for example, up north, that could be a spring wheat, Montana, North Dakota, Minnesota, for example, could be a spring wheat. It could be a soft wheat. So we have different classes of wheat. In Arkansas, it would be a soft white. It would be a soft red. It'd be a soft red winter wheat. So the classes of wheat change depending on which geographic area you're in. And they all respond differently to nutrients. But the general theme would be basically the same. No matter which one of these you're working on, you're looking on trying to develop wheat that's going to be the best for that environment. If there's a disease problem, an insect problem, you're breeding for resistance.
Mm-hmm.
These also wheats have a different fertilizer requirement.
Mm-hmm.
So you have to determine what those are. So you'll be doing similar things even though the classes of wheat are different.
Okay. Now, where do you see the Magruder Plots heading into the future here? Is it going to continue or?
If as long as we can possibly continue those plots, they need to be continued.
Mm-hmm.
Hopefully, since we've got them in the register, historic register, they'll continue from now on. But like I said, those plots are the living history, I guess, of the reddish prairie soils as far as nutrient depletion is concerned.
Okay. Now, can place the plots within the context of Oklahoma A&M and OSU history. What has been their role? How are they perceived? And what kind of attention do they bring to the university?
Surprisingly, we have a very, very large number of alumni that across the state
Mm-hmm.
that have come through Oklahoma State University, Oklahoma A&M at the time, that have had the privilege to work on those plots as students, whatever. So we have a large clientele for support. As far as historical significance,
Mm-hmm.
like I said, it's the oldest wheat plots in the Great Plains area and second oldest west of the Mississippi. So it has a high degree of recognition, not only locally, nationally, but internationally.
Mm-hmm. Now, do you think that'll be a permanent fixture here on campus?
I'm going to say yes.
Okay. Now, okay. Now, you left the Magruder Plots working with them and came to administration. Can you detail us a little bit about what you've done since 1991 here as your role?
Yes. I became department head of the agronomy department at that particular time, 1991.
Mm-hmm.
And I served, we changed the name of the agronomy department to the Department of Plant and Soil Sciences. And I served in leadership capacity of the department for, I believe, 11 years.
Mm-hmm.
And so had a lot of experiences with not only with the soil fertility aspect, but with crop breeding, weed control, weed management. So I got a chance to really be in a supervisory role for a wide number of programs.
Mm-hmm.
After that particular period of time, I joined the Oklahoma Agricultural Experimentation Administration as the assistant director.
Mm-hmm.
And with that experience, of course, we have agricultural experiment stations in every state.
Mm-hmm. Every state?
Every state.
Yes.
Plus Puerto Rico, Guam, and the Virgin Islands. But began to work more on a national, international level.
Mm-hmm.
And then, of course, since I moved into my current position, I have the privilege of working for all of the programs, the college, experiment station, and cooperative extension service. So it's been a broadening experience.
Mm-hmm. Now, what have you seen as like the biggest evolution of the College of Agriculture here in all your time?
Well, think one of the biggest evolutions that we have had is the basic training that our scientists have today compared to some of the earlier years. We have people that are trained in the very basic sciences, molecular, at the molecular level. And so we've kind of expanded our faculty working group to include more molecular aspects of our program than we did originally in those quote earlier years. First of all, the science of biotechnology has only been recently generated in terms of the history, I guess, of the department. So we're able to move genes out of one plant into another plant more readily. We're also able to move desirable traits from one plant to another more quickly with some of the techniques that we have available to us today.
Now, what about changes towards the university? What have you seen? What do you think it's been the biggest change?
At the university level?
Yes, at the...
Well, certainly, presently we're undergoing one of the greatest expansions of facilities, I guess, that probably the university has ever had the privilege of being involved in, with all the things such as a multidisciplinary science lab across the street, everything. So we've had a marked change in the facilities that we have and our scientists have to work with. That has been very, very beneficial for us to maintain competitiveness for national grants and also to help us move our programs forward.
Now, one last question here. Do you consider yourself an Aggie or a cowboy?
That's a difficult question. That's a difficult question. I guess I would have to place myself as a cowboy. When I came up here in 1958, that was the first year, I believe, that, or might have been 1957, when Oklahoma A&M College was changed to Oklahoma State University. So my experience here has been as Oklahoma State University, and I think the Aggie term is more appropriately relates to those folks and alumni that may have come through as Oklahoma A&M College.
Okay, so a cowboy then.
Yeah. But I'm proud of each of them.
That's right. Since I had to ask, since you're still within the College of Agriculture. Yeah. Now, is there anything you would like to add before we end this interview? Anything you'd like to share that we didn't discuss?
No, the only thing that I would hope is that you continue to preserve the valuable history of the Magruder Plots, of all of the agricultural experiments that we have. This is the one we have the longest history with. This is the one that is the most well documented. In 100 years from now, the value will have increased markedly. And so I would just encourage everyone that has the opportunity to be involved in the experiments to fully document their activities and make sure that they're archived properly and the best history recorded as we possibly can.
Okay, we'll take that advice. Well, I appreciate the time that you shared with us, and Best wishes as with your current and future endeavors. Thank you.
Thank you.